Yeah, good morning, everybody. Happy Monday. Welcome back. Hope you had a super weekend. Yeah, you know the drill. Let's get busy. Okay, I'm a little late getting this out. So go ahead, copy it down. Do all you can do. Come back for hints, or at the very least, come back to check your answers and follow along with me as we go over it. Okay. All right. See you soon. And that was soon 256. I know you want to write 16 times 16 here, huh? That doesn't work when you add, though, huh? Right. All right. So let's double the 16, get 32. Take half of the 16, get 8. 8 times 32 is also going to be 256. What's 8 plus 32? Well, that's 40. Let's do it one more time. Double the 32, get 64. Take half of the 8, get 4. And 4 plus 8 is 68. And 4 60s is 240. 4 4s is 16. 240 and 16. Boom. Got it. All right. A little stumper one for you to start the day, start the week. This one gets easy, though, right? 6/10 and 7/10. When you add, you line up those decimals and stack them, right? The decimal comes straight down when you're adding. 6 plus 7 is 13, carry the 1, so that's 1.3. When you multiply, you go 6 times 7 is 42. But in order to pretend that was a 6, I had to move the decimal one spot to the right. In order to pretend that was a 7, I had to move that decimal one spot to the right. That's a total of 2 spots. I have to go back 2 spots in my answer. Now, see what I did. I was counting the spaces I had to move the decimal. Don't just go 1 decimal, 2 decimal. Then you would do it wrong and get it right. And that's dangerous. When you can do it wrong and get it right, you walk away thinking you did it right, and you don't pay attention, and you make mistakes going forward. So let's not do that, all right? Be careful. All right, what's going to work here? We've seen this before. I know it's a stumper problem, but this ends up being 4 times 2.5. 4 twos is 8. 4 halves is 4 over 2. This is 2. 8 and 2 is 10. And 4 plus 2.5, 6.5. This one we've seen too, but maybe you don't remember, or maybe you're new here doing the warm up. 3 threes is 9, and 3 thirds is 1. 9 and 1 is 10, and 3 plus 3 1/3 is 6 1/3. Okay. Hopefully you'll stay though, right? You'll keep coming back and doing these, and then these will become easier for you. All right. 90 plus what is 360? 4. 30 times 90 is 3 times 9. But I'm going to move the decimal over 2 spots. And 30 times what is 30? Huh? Did I make a mistake? Oh, that's going to be a 1. And 1 times 4. All right. So I go add these. I get 2,700, 360, 30, and 4. And I get 3,094. Now, it's said to use the standard algorithm to double check my work. So I have 91 times 34. Right? I'm going 4 times 1, 4 times 9. Put a placeholder because that's really a 30, not a 3. 3 times 1, 3 times 9. Go add and check it out. Same answer. Good. Must have done it right. All right. 6 times what is 2,400? Well, 6 times 4 is 24, but I'll move the decimal over 2 spots. That must be 400, which makes sense. If that's 3 digits, 4, that's a hundreds place. This is the tens place, right? And that's going to be the ones place. Ones place. 6 times what is 6? Oh, similar, huh? So 1 times what is 30? 30 times 400 is 12 with 3 zeros, 12,000. And 30 times what is 600? And don't put a 30 up here. 3 times 2 is 6. Okay. And then 6 times 20, 120. Let's go add, see how we do here. 12,600, 2,400, 120, 30, and 6. 6, 5, 10, 11, carry the 1, 5, 15,156, and we're going to double check. How do we do that? 421 times 36. Let's go ahead and use the back on that one. 6, 12, carry the 1, 24 plus 1, 25. Placeholder because that's really a 30. 3, 6, 12, 6, 5, 11, carry the 1, 15,156. Boom, high five. All right, you guys, solve this. Remember, what is our goal? Our goal is to isolate the variable. I want the x by itself on one side of the equal sign because then I have the answer. But that's called isolating the variable. Right? How do I isolate the variable? I get rid of everything else. So the first thing I'm going to do is go in reverse order of operations. I'm getting rid of the simple things first. I'm getting rid of the things farthest away from the x. So the plus 5 and 2/10 is what I'm getting rid of first. Okay, so I'm going to rewrite this, but instead of writing 4x, what is that? That's 4 times x. I'm going to write x times 4 plus 5 and 2/10. Give myself some room to do the opposite. What's the math term for opposite? Inverse operation. I'm going to do the inverse operation of plus 5 and 2/10. What is the inverse operation of plus 5 and 2/10? Hopefully you said minus 5 and 2/10. And if I put those things together, they cancel each other out and they go away. Poof. But if I do that, I subtracted 5 and 2/10 from this side of an equation that was in perfect balance. Now it gets light and it's leaning. How do I make sure it stays in balance? Do the same thing to the other side. Yeah, and you notice that whenever I do this, I try to use another color ink so you can see everything's the same except for this and this. Same thing both sides. Okay, now this and this cancel each other out. So all I'm left with on this side now is the x times 4. And on this side, I have 30 minus 5 and 2/10. Let's figure out what that is. Now, I have to line up the decimal. Where is the decimal in 30? Hopefully you said it's there, right? If there's, you can't see it, it lives on the right side of it. You can put it there if you want, and I need to, so I can add a 0 and subtract and not get a mistake. See, I have to borrow here, right? So this is 29 and 10/10. And then 29 minus 5 is 24. So now I have my equation. What's left is x times 4 equals 24 and 8/10. How do I get rid of a times 4? What's the inverse operation of times 4? Well, hopefully you said divided by 4. And if I divide it by that side, do the same thing to the other side to stay in balance. And again, you see I did it in red ink, so you can see that's the only thing that changed. Now, I can circle these, and you realize that those cancel each other out. If I multiply by 4 and divide by 4, I'm back where I started with, right? All right, so now all I have to do is figure out how many times does 4 go into 24.8. And again, when you're dividing and there's a decimal inside the box, do you know what you have to do? Do you know all the steps? Watch closely. Boom. That's all the steps you got to do. If there's a decimal inside the box, that's all you got to do is bring it up and divide. Outside the box, we'll learn about that later. It's a little bit trickier. You got to get rid of it before you can divide. 4 goes into 24 6 times. That's a perfect fit. And it goes into 8 2 times. So I end up with 6 and 2/10. Now, are you done? Hopefully you yelled, "No, I'm not done. You said I always have to." Check my answer, right? If x equals 6 and 2/10, I should be able to substitute 6 and 2/10 and for x there. Now that's not going to be 46 and 2/10. It's 4 times 6 and 2/10 plus 5 and 2/10. Does that equal 30? Okay, well, 4 times 6 and 2/10 is like 4 times 62. And then when I move a decimal, I get done 248. Now, that was really 6 and 2/10. So I moved the decimal one spot. I got to go back one spot in my answer. 24 and 8/10 plus 5 and 2/10 equals a nice even 30. Boom, you did it right. All right. Subtracting. How many fifths are with that 10? There are no fifths with that 10, huh? So when I stack these, I'm thinking, ooh, and you know what the most common mistake is on this? People just bring down that 2/5 and go 10 minus 4 is 6, and their answer is 6 and 2/5. You're not supposed to bring it down. You're supposed to subtract it from something. And if there's nothing up there, there's 0/5 up there. Go ahead and write 0/5. And that will lead you, hopefully, to say, wait, I got to borrow. And when you borrow, hopefully you don't cross out that 10, put a 9, and put a 1 there, because then you're saying that that 1 I borrowed is equal to 10 fifths. Is 1 equal to 10 fifths? No. 1 is equal to how many fifths? 5. So I had 0, I borrowed 5. Now I have 5, take away 2, and 9 minus 4. 5 and 3 fifths. If you got 6 and 2 fifths, go and look at that again. Rewind it and go watch again and see how we do it. Okay. And all I really did is I rewrote the 10 as 9 and 5 fifths, which is 1, right? So that works. All right. 3 and 4 is 7 and 1/2 and 3 fifths. I got to add. And 1/2 is how many tenths? 5. 3 fifths is how many tenths? 6. 5 tenths and 6 tenths is 11 tenths. And that sounds weird, huh? That's like me saying I'm 5'20". Well, I am. Okay. But yeah, that's not how people like to hear it. 10 tenths is 1 whole. That's going to make that an 8. And if I use 10 of those tenths, 11 tenths, I got 1 left. So 8 and 1/10. Okay. I'm going to go ahead and write these one on top of another because there's a few different things going on here. I tell some kids, sometimes this is the toughest type of problem. You have to subtract a fraction of its number with unlike denominators, and you're going to have to borrow. What does that mean? Well, ninths and halves don't work. Let's change them to 18ths. I did 9 times 2, so I go to 2 times 2 is 4. I did 2 times 9 to get 18. I go 1 times 9. And I can't take 9 away from 4. So what do I got to do? I got to borrow. And I borrow from that 16, and I don't put a 1 in front of it, because what am I doing? I'm borrowing 18ths. How many 18ths is equal to 1 whole? 18. But I don't put 18 there because I already had 4. 18 plus 4 more. Now I have 22 18ths minus 9 18ths equals 13 18ths. And now I have 15 instead of 16. Minus 3 equals 12. And just like that, you're ready to go on with your day. Happy Monday, everybody. Have a good one.